Okay, so 6.6, graphing a system of linear inequalities. So when graphing a system of linear inequalities, you're first going to want to write the inequalities in the function form. So meaning you're going to write inequalities in function form, y equals mx plus b. Graph the first boundary line, solid if or equal to, dashed if it's less than or just greater than. Shade above or below the line using the symbol. Repeat with the remaining inequalities, and then the highlighted areas that include shading from all inequalities is going to be your solution of the solutions. Okay, so what is the graph of the system? So this first one is already written in. Oh. This is terrible. Does that work? Tell me if I'm off the graph. Alright, so looks like it's. Who's going to be watching this anyway? Maybe people in her class. Oh. Alright, so y is greater than negative x plus 5. So I start with plus 5. I would go right here, correct? Because this would be between 4 and 8 is 6. So between 4 and 6 is 5. And then a negative, so I go down 1 over 1. Down 1 over 1. Okay? And it's or equal to, so it's going to be a solid line. Okay, and then, so that's, I shade anything that is above it. So what I like to do is I like to take a highlighter, 2 different colored highlighters, one green, one whatever color, and then when they mix colors, that's where the solution is. Okay, this negative 3x, so I need to get this into the correct form. So 3x, add 3x to both sides. So I have y is less than or equal to a positive 3x. Do I have to write that? No. And then minus 4. Okay, then I start with minus 4. I'm going to take a different color. So I'm going to go down to negative 4. Put a dot, and then I go up 3 over 1. So up 3 would be to the 1 and then over 1. Oh, did I go over 1? No. Let's see. I went over 2. So this is 2 points. Oh, man. I think I went down 1 over 1. Should have been here then. Oopsie. Oh, I made a mistake. Down 1 over 1. So my graph would look a little more like this. And then that would be shaded. Sorry about that, folks. Okay, so up 1 over 1. So up 3 again, so 1. So up 3 over 1. And then I would connect it. It's again or equal to, so I can draw a solid line. I'm going to use a different color, so this time it's going to be less than. So it's going to be below the line. Shh. So it's where the 2 colors meet. So anything in here, I want to make sure that this is a little darker. So I have just green here, green and orange here, orange here. So this is the solution, or this graphing. So determine if each ordered pair is a solution to the system. So these numbers are going to work for both of these equations. The green are going to work for just the top one, and the orange is going to work just for the bottom ones. Okay, so 5, 0, over to 5 would be here, up 0, so yes. 8, 4, so over to 8 and up to 4, that would be a yes. Over to 1 and up to 4 would be here. Nope, would be here. So that would be yes. Over to 4 and down to -4, that would be no. 5, 5 would be 5 and then up to 5, yes. Shh. 0, 5, so 0 and then up to 5 would be a yes also. Okay. Okay, so this one I need to get my minus x. So we have y is less than or equal to a negative x plus 5. So I'm going to graph that, go up to 5. And then my negative slope, or -1, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. It's going to be a solid line. Shh. And it's going to be y is less than. So it's going to be less than it. So I'm going to highlight like that. Hey. Shh. My goodness, how many times do I have to do? Okay, and then this one is already in my y-intercept form, so I'm going to go up to 3, put a dot, and I should use green because you can really tell with green. So up to 3, and then go up 1 over 1, up 1 over 1. And it's a less than, so it's a dashed line. So if you ever write it in pen and then do that, then it's a dashed line. Okay, and I want to shade anything below it because it's less than, so it's going to be all of this below it. So this part in here where it's both is going to be shaded darker. It's going to be both. 2 colors. Done. Determine if these are solutions. Well, if they're in this part, it is. So 1, 1 would be yes. -3, 0, that point right there, yes. -2, 5 would be no. 3, 2, 3 up to 2 would be yes. 1, 4. Right here. So remember this point right here, this one is at my dashed line. This one is a solid line, so it would be true for this one because it's on both of the lines, right? It would be true for this one. It's not true for this one. It's got to be less than. So if you look at this one right here, 1, 4, 1 plus 3, 4 is less than 4. Is that true? No. So this would be no. If it's right on the line, you have to look if it's dashed or not. And then 2, -2 would be yes. Okay. Don't remember how far we go here. Oh, yeah. Okay, so then I'm going to skip that second example. I'm going to skip this one. Okay. I'll go through it. It's kind of quick. Don't let me get to 15 minutes. So y is greater than 1. So dashed line. So I should be using pencil so I can dash that line. And then it's anything greater than, so it's going to be up. So let's do Okay, and then x is less than or equal to 4. So x, solid line at 4. And it's less than or equal to, so let's do anything less is going to be this way. Okay, and then our last one, we're going to divide everything by 3. So we have y is less than 2x minus 2. So my first dot, or my first point is the y-intercept at -2. And then up 2 over 1. Up 2 over 1. It is a dotted line, so I'm going to try and get that first. First time ever doing it. Without having to. Okay, and then I do need another color. Here, there's blue in here. And then anything less than it, so anything to this side, that's a terrible color. I need blue too. Oh, where's my purple? I have purple too. So it's anything this way. So we have orange, which is this way. We have green. That's this way. Right? So this point right in here is a solution. Is where the solutions for all of them, all 3 of those inequalities would be. Part is going to be writing a system of inequalities from graphs. So first here, you have to look at where's my y-intercept. My y-intercept is at 1. So it's going to be plus 1 for this one. And my slope is from here to here. So I'm going up 1, and to the right 2. So it's a positive 1/2. And then I have y. So I need to figure out if it's less than or. So if it's this way, if you notice it's darker here. So this is where they meet. So this graph would be going this way, and this would be going. I can't really tell where they meet. Can you?
No. I think it's down here. I missed the bottom part.
It is, you think? So this is going this way, and this is going this way?
Yeah.
Okay.
Sure.
I thought it looked darker here for a second, but whatever. Okay, so I have to decide this way it's being shaded. Well, and it's going to be less than. So less than, and it's a solid line or equal to. Okay, and now I have to graph this one. And if you notice, y is still going to be less than or equal to. We have up 1 to the left 2. So it's a negative 1/2 x, and it's still plus 1. So really, to write an equation in slope-intercept form, you need the slope and the y-intercept. Did I do it wrong? Oh, yeah, correct, sorry. It's not equal to. Good catch. Yeah, it's just less than. It's not or equal to. Okay. So here, this one will be the easiest. Y, and it's shaded this way, right? So y is greater than, it's not equal to, greater than, is that number -2? And then my diagonal line would be y, it's got to be less than, right? Or equal to, I need my slope of up 1 over 1, so a positive 1x, and then my y-intercept is a -1.